What's up, good people? What's up? This is Percy. So in this video, you're going to be learning about the laws of exponents. Exponent good laws, by the way. So there's 5 of them. It's not a lot, and they're easy to remember. The first one is this one. The second one is this one. I'm sure you probably have seen one of these laws in your classes. So I'm going to be doing a revision of that, and then I'm going to be showing you some examples and how to apply these examples and how they will ask you. Okay, so let's get into it. Boom. So first law, we don't even need to know the order of the law. Doesn't matter really. So I'm not going to even say first law. So let's say dot law. No particular order really. So suppose you got A. A is an any number, power m times A power n. These are anything. These are any numbers, any real numbers. Okay, any real numbers, a and b and m. These are any numbers, and you get a power m times a power n. So if you have a situation like this where bases are the same, right? Bases of the exponents are the same. If the bases are the same, that's the condition. If the bases are the same and you're multiplying, therefore you just have to add the exponent. So if the base is the same, you just write the base and then you add the exponents. The reason you're adding exponent because you are multiplying. Okay, so if we have a situation like this, what about then a power m divide by a power n, which can also be written as a power m divide by a power n. So if you are dividing, you're no longer multiplying, you are dividing, and the bases are the same. You're doing the same things. Okay, cool, I keep the base, but with the exponent you then minus the exponent. So it's going to be say m minus n. So you start with this one minus that one. Okay, start with this one minus that one. M minus n. If you divide, you minus. If you multiply, you add the exponent, provided that bases are the same. Bases are the same. Bases are the same. Okay, that's the condition. Another law is this. Let's say you got a times b, or rather a times b, and then this is power n. Okay, so the way you write this will be a power n times b power n, or you can write it as a power n b power n. Doesn't matter. The times can be, in mathematics, that this multiplication sign can be also be silent there. You have an option to put it, you also have an option not to put it. Still the same thing. The notation is acceptable. So this can be written as a power n and b power n. Okay, a times b power n, this is going to be a power n times b power n. Then another one, let's say you have, because now we're looking at the multiplication, let's say you have the division. So a divided by b power n, or a over b power n. Okay, so this could be written as a power n over b power n. It makes sense. It definitely does make sense. Let me give you another one. So you have a power m power n. So now it's 2 exponents. So this can be written as a power m times n. Okay, a power m power n, 2 exponent, that could be written as a power m times n. Right, so these are the laws of exponents. They're easy to remember and they're easy to apply. And I'm going to give you a couple of examples. Probably as many examples as possible. I'll see. So let me give you first example. Let's change the color. First example. Let's say you got 2 power 3x. Yeah, times 2 power 4x. Okay. What did the law say? The law say, let me write a different color as well. The law say if we have a times, let's say power m times a power n, bases are the same and you're multiplying, so you add the exponent. So again, bases are the same, right? So you write the base, this is 2, and then what I do, I add the exponent. This is multiplication sign, so I'm going to add the exponent. So it's going to be 3x plus 4x. Now, what is 3x plus 4x? That is 7x. So 2 power 7x. Does this make sense? Okay, I'm going to give you another one. Let's say you got x power 3 divided by x power 5. Okay, look, bases are the same. So I write the base. That's good. And you're dividing, so you're going to minus the exponent. That's going to be 3 minus 5. You're minusing the exponent because of this rule. If you have a divided by b, and this is a, let's call it m, let's call it n, this is going to be m minus n. That's the rule. So that's what you're going to be up. That's your answer. And your answer here essentially is x power 3 minus 5 is minus 2. 3 minus 5 is minus 2. That's your answer. And on my previous videos, please check it out on the identities of exponents. X power negative 2 is equal to 1 over x power 2. Please check that out if you don't know that. Let's go number 3. That one. Number 3. Let's say you got 4. Let's give you the same example. 4x power 3 divided by 2x power 5. Okay, you got those two ones. So how do you do this? So in this case, again, you're looking at exponents. So don't be confused about the coefficient of the exponents, or the coefficient of the base of the exponent. So because 4 over 2 is 4 over 2. 4 over 2 is 4 over 2, and you know what is 4 over 2. 4 over 2 is 2. 4 divided by 2 is 2. So you got 2 power x3 over x5. So this is what you have. And this is going to be 2 times, you already worked that out. So this is going to be x power 3 minus 5. And this is 2 times x power negative 2. And this is 2 times x power negative 2 is 1 over x2. And this is 2 times x power 2. Does this make sense? Please let me know if it makes sense. Please let me know. If it doesn't, also let me know. I'm happy to go through it with you. So let's go to number 3. Okay, so you got 12p squared t power 5. Yeah, I'm making it a little bit complicated now for you guys. Okay, cool, let's go. So you got 12p squared t power 5 over 3p t power 3 t cubed. So this could be written again. Remember, don't be confused about these things. You're looking at bases and exponents. These are things that you're going to be applying the laws of the exponent. But 12 over 3. We know what is 12 over 3. 12 over 3. 12 divided by 3. 3 is 6, 9. 12, that's 4. Right? That's 4. 12 over 3 or 12 divided by 3 is 4. So we know that. So let's not be confused. We have p squared t power 5 over p t3. Great. Now let's apply our laws of exponents. So remember, you're looking at the bases that are the same. So p and p are the same, and you're dividing. So what you're going to do with the exponent? You minus. Yes. So it's going to be p power 2 minus 1. Remember, this is power 1. Power 1. P is equal to p power 1. If you don't know that, please check my videos on identities of exponents. Okay, so this is p power 2 minus 1. So again, we applying this law, this law. A power m over a power n is equal to a power m minus n. Okay, and then again, we see t and t are the same. T and t are the same. So you're gonna have this times t power 5 minus 3. T power 5 minus 3, so it's 4 p power 2 minus 1. 2 minus 1 is 1 times t 5 minus 3 is 2. And p power 1 is essentially p. And your answer is 4p t power 2. And that's your answer. I hope this makes sense. Okay, let me give you another one because I like it so much. So let me give you another one. Let's say you got 3x power 2. Now, what does the law say about this? There's a law says if you have a and b power n, this can be written as a n times b n. Okay, so we can write this like this. This is 3 power 2 times x power 2. And what is 3 power 2? 3 power 2 is 9. 3 times 3, that's 9. So it's 9x squared. That's your answer. Okay, we're getting somewhere. Let me give you another one. Let's say you have 3 power 4, 5 squared, and 3. I mean, let's say you simplify this without a calculator. Okay, let's forget about the calculator. Let's use the laws of exponents. How do you do this? Remember, the laws of exponents says if a and b power n, this is equal to a power n times b power n. So this could be written as 3 power 4 power 3 times 5 squared power 3. Now, we jump to another law of exponent. If you have a power n times m, this can be written as a power n times m. So we do the same thing here. So this could be written as 3 power 4 times 3 times 5 power 2 times 3. Does this make sense? These laws of exponent, they come naturally and they just make sense, man. So this is 3 power 4, and 4 times 3 is 12. And 5 times, so 2 times 3 is 6. And that's your answer. That is your answer. Okay, let me give you another one. I want to give you as many examples as possible. And I love P because P stands for Percy. Right, so in this case, we're going to be using these laws of exponent. I mean, one of the identities we know that p power 0 is 1. We know that identity. P power 0 is 1. Or rather, let's just write this way. A power 0, a is any number or any value or any real number, is equal to 1. A power 0 is equal to 1. So in this case, 6 p power 0 is 1. Okay, times, and anything power 0 is 1. So this whole thing is 7p power 0 is 1. Okay, so I write 1, and this is 6 times 1 times 1 is 1. So 6 times 1 times 1 is 1. So that's your answer. Easy. Let me give you number 7. Man, I want to step it up a little bit. Let me give you another one. Are you not entertained? So here we're going to be using everything that we just learned. Okay, now what do we know here? We know that if you have a over b power n, this can be written as a power n over b power n. Okay, so let's apply that. This could be written as 2xp cubed over 6x squared cubed. Aha! Now, what do we know again? We know. Let me take you this outside. Let me take you this other side. Let me take you on the other page. On the other page. On the other page. On the other. Okay, so we know that if you have a times b power n, this can be written as a power n times b power n. So that's what we're going to be doing here. So this is going to be written as 2 power 3 times x power 3 times p power 3. And this could be written as 6 power 3 times x squared power 3. Okay. And another one, I see that if you have a power m times n, this could be written as a power m times n. So this is going to be, so we know 2 power 3 is 2 times 2 times 2. 2, 4, 6. So it's 2. No. It's 8. 2 times 2, that's 4. 4 times 2, that's 8. 8 times x cubed times p cubed over 6 times 3. Again, 6 times 3 is 6 times 2 is 12, and 12 times 12, so 12 times 6. No. 6 times 6 is 36. 36 times 6 is 216. So it's going to be 216 times x power 2 power 3. Okay, if you don't know this, just find your calculator. Okay, calculators are fine sometimes. All right. And 8 divided by 216, that's actually 1 over 27. Okay, punch that in your calculator, you get it. And then you got x power 3, p power 3, and x power 2 times 3. 2 times 3 is 6. So you can just write 6 there. Okay, it's 1 over 27. And guess what? You got x and x are exponent. You got p. P doesn't have another exponent, so we're just going to keep p the way it is. And times x. So x is x, you divide. So the rule says if you have a power n, b power, again it's a's, the bases should be the same. So this is going to be a power n minus m. Okay, so this is going to be x, so 3 minus 6. So got 1 over 27 times p cubed times x power negative 3. And that is your answer. I mean, this answer can be written like this, by the way. You can actually still simplify it further. Let me just come back to the question. Oh, the previous result. Okay, so this can be written as p cubed x power negative 3 over 27, and this still can be written as p cubed over, I mean, we know if you have a power negative n, this can be written as 1 over a power n. So we know therefore x power negative 3 can be written as 1 over so we got 27. This can be written as 1 over x power 3, and that's your answer. That could be your final answer. So yeah, I hope this makes sense. I hope this whole thing makes sense and getting more and more complicated and more fun. But let me give you a last question. Last one, I promise. So this is 2 power let me see, negative 2x plus 1. Don't use a calculator, please. Calculate this for me. If you got the answer, let me know. Write your answer down in the comment, and I'm keen to know what is the answer for number 8. And yeah, so if you don't know the answer, please let me know. If you don't know the answer, I'll give you the answer as well. But I'll see you in the next video. Thank you for liking and sharing and commenting and subscribing and following me. I'll see you in this video.